Hello. Let's talk about what happens when waves reach another medium. In this case, we'll talk about reflection. When a wave goes from one medium to the other, let's say we're talking about a wave of sound traveling through the air and it hits a wooden door. What could happen to it? Well, three things could happen. One, it could be reflected. Two, it could be absorbed. Or three, it could be transmitted. This video is going to focus on reflection. And in this case, reflection just means it's bounced back into the same medium, so it stays within the air. The key thing to know about reflection is something called the law of reflection. That says basically that the angle of incidence equals the angle of reflection. The angle in equals the angle out. So if we're talking about a surface here, what you have to do is compare it to the normal line. Recall that normal means perpendicular. So if you take the surface and draw a line perpendicular to it, your angle of incidence, the angle at which it comes in, must equal your angle of reflection, the angle at which it comes out. So if my angle of incidence here is 30 degrees, my angle of reflection must also be 30 degrees. If the angle in were 50 degrees with regard to the normal, then it would be 50 degrees out with regard to the normal. In equals out. This is true for all waves in all cases. There are no exceptions. However, if we are talking about the reflection here, one of the things that we have to realize is that even if objects are shiny, even if they are reflective, nothing is 100% shiny. So although waves can be reflected off of any surface, not every 100% of it will be reflected. Consider the case of a mirror. A mirror is extremely reflective. You're able to see a lot of the incoming waves, in this case light, reflected back at you. However, if you had the case where you had an infinite series of images, one where you put a mirror up against another mirror and check into it, you'll notice when you look at the first image, it seems pretty bright. But as you go back further and further and further, you might be able to notice that it's getting dimmer and dimmer back there. That's because although a mirror might be able to reflect well over 90% of the incoming light, it does not reflect 100%. So eventually some of the wave is either transmitted through or, more likely in this case, absorbed. We know that light can be absorbed because if, again, you're outside, you would absorb the light coming from the sun and you would heat up. So although waves can be reflected, some of it might be absorbed. What we see are only things that are reflecting light. Unless an object itself gives off light, everything we see comes from a reflected source. So as you are outside, you are looking at, say, your skin, your hands, because light is being reflected from your hands into your eyes. Without the sun or without a light bulb, you can't see your hands because they themselves don't generate light. So reflection is responsible for nearly everything we see. There are a number of uses for this, one of which might be something like a fish finder. With a fish finder, something like sonar, basically a pulse is sent out. When it hits something, that wave is reflected back to the receiver and it translates it into, this is how far away it must be. It knows how far or how fast that the wave will travel. It knows the time it took for the pulse to get back, and therefore can calculate the distance to the object. So reflection is used for things like sonar, like finding objects underwater. The same idea could be put towards radar. Radar guns can determine things by reflecting radar waves back to the sensor. Radio waves bounce off the atmosphere. So inside our atmosphere, we have several different layers the ionosphere is capable of reflecting back radio waves. So an AM radio works by bouncing its signal off of the atmosphere. Because of that, AM radio stations are able to be heard miles away from the source tower. On the other hand, TV signals, which are a slightly different frequency than radio waves, are not easily reflected, which is why most TV signals are carried through things like cable or satellites. Another really interesting idea for reflection is something called the hologram. In a hologram, you might produce a virtual image by reflecting light beams. So here I have a picture of a toy. It's called the 3D Mirroscope toy. Light comes in and bounces off an object at the bottom. It then interacts and comes back up top here, so it looks like the object is not on the bottom, but actually is resting here. Because again, we see objects because they reflect light. If the light is reflected to the same spot, we're going to perceive the object being there. It is, however, not real. If you were to go and actually try to touch that object, it wouldn't physically exist. This is the concept behind, again, a hologram. By reflecting light into a certain position, you're just reflecting off where the object is, but itself does not exist there. Really cool little toy. Even if the surface is not flat, the waves must follow the law of reflection. So if you consider something like, say, the mirrors in the back of stores, you might notice that they show a much greater area. That's because they spread out the light. By spreading out the light, it makes it look things smaller. If you make the light go towards a smaller point, you might make things look a little bigger. This is the idea of convex and concave surfaces, ones where are curved. You can even do this where you have light being upwards or flipped over depending on the distance you are from the mirror. So reflection is always true. It's always going to follow the law of reflection, but if your surface is not flat, you might be able to screw with it a little bit. This is most easily seen on something where you have a completely regular surface versus a flat surface. In a flat surface, we would get regular reflection. Every light comes in, bounces off at the exact same angle, so they're all remaining parallel. Say you're looking at a picture of, or you're looking at a lake that is perfectly flat, perfectly placid. It's almost like the area behind it, the sky behind it, is reflected in the water. Because the lake is perfectly clear, perfectly flat, you'll see a perfect reflection. If, however, it's raining or somehow it's been muddled, you can still see a reflection out of that. However, the picture itself is not as easily seen because as the light comes in, it still hits the surface, it still goes off from the normal, from that surface at the same angle, but because the surface is no longer flat, they might be going all over the place. Since the waves no longer line up, it doesn't look like a regular image to you. You can still see light reflected off of the water. You can still see here it's reflecting some colors of the tree above it. However, because it's not a flat surface, it doesn't have a regular reflection. The reflection is very diffuse, so the image doesn't come out very clear. Reflection occurs, but in a way that we can't understand or recognize the image. So this might be a case where we have something like sound waves. If you had a sound wave in a completely empty room, it would reflect very easily off of the hard surfaces, and you might get a lot of echoes. However, if you put in a room things like curtains or carpets or furniture, because those surfaces are not flat, they're not smooth, that would diffuse and disperse the waves, making it muffled. You wouldn't hear easily an echo coming from those surfaces. So reflection always occurs, may not be 100%, but it always occurs. However, if you have a rough surface, the reflection may not look like it does or sound like it does normally.